So this video is on anti-differentiation or integration, which is the opposite of taking the derivative. We call it taking the integral or integrating, or you can refer to it as anti-differentiation. So if I take a function like f of x equals 3x squared plus 7, and I were to take the derivative, which is f prime of x, we know that we multiply and then subtract. So this would be 6x to the first power plus 0, because the derivative of a constant is 0. So we multiply the exponent times the coefficient, and then we subtract. So what we want to do when we integrate is to go backwards. We're undoing what we did, and we want to go back to the original function. So what we do is, if we were given this, we're asked to integrate it, we would work backwards. So the last thing we did was subtract, so now we want to add. So we want to add to this exponent, so it's x to the second. And then before that we multiplied, so we want to undo that, so we want to divide. So we're going to divide by 2. So you're adding and dividing, which gives you, if you reduce this, 3x squared. We had a constant, we took its derivative, and we got 0, so we don't know what that constant is, so that's impossible to go back to and know for sure without some other information, so we just say plus c as in some constant c. So that's the original function, and that's how you go backwards, and that's integration or antiderivatives. If I wanted to know the exact value of the original function, I'd have to be given some piece of information, and we call that an initial condition. Like, for example, if I knew a solution to this, like if you plugged 1 in here, 1 squared is 1 times 3 is 3 plus 7 is 10, so you have the solution 110. So if I knew one solution from the original function, that would be called an initial condition. And so this is called an antiderivative, not the antiderivative, because this is the original antiderivative. So we call this an antiderivative. And so if I knew the initial condition that when x is 1, the function equals 10, then I'd be able to plug it in and say 3x squared plus c equals 10 when x is 1. So I plug 1 in, and 1 squared times 3 is 3 plus c equals 10. Subtract 3 from both sides, and I get 7. And so I would know that c is 7, and I would know the original function was 3x squared plus 7. So in order to get the exact antiderivative, I would need an initial condition. Okay, so let's look at a couple of examples. If I was trying to, this is the symbolism too that we use. This means I'm taking the antiderivative, or I'm integrating 3x. I'm trying to go back to the original function. So I would add 1 to my exponent, making it x squared, and then I would divide by 2 and add c. And this is the final answer, unless you want to write it as 3 over 2 x squared plus c. Okay, and that's integration. That's taking the derivative, the antiderivative. I'll just do a few more just to show you some things that could occur. If I was taking the antiderivative of this, I would rewrite it first and call it x to the negative 3. And so now when I add 1 to this, I would get negative 2, and then I would divide by negative 2, so and plus c, and then my final answer, I would write it as negative 1/2 x to the second plus c. This x to the second is in the denominator, I just moved it down. So I changed it from a positive exponent to a negative, and then in the end I put it back to a positive exponent. Okay. You could do the antiderivative of square root of x. Again, before I did it, I would rewrite this as x to the 1/2 dx. I need to add 1 to this. When you add 1 to a half, you do it in the form of 2 over 2. So you get x to the 3 over 2, and then you're dividing by 3 over 2 plus c. Dividing by 3 over 2 is the same as multiplying by 2/3. X to the 3 over 2 plus c, and that's the antiderivative. And I'll do one more just so you can see a trig function. I'm going to probably stick with just sine and cosine for now. So we know that the derivative of the sine is the cosine, and the derivative of the cosine is the negative sine. And we want to go back to the original function, so the answer here would be negative 2 cosine x plus c. Because I know if I take the derivative of the cosine, I get negative sine, but I need this to be a positive, so it's negative cosine. The derivative of negative cosine is positive sine, and the constant just stays the same. And that's pretty straightforward. And that's anti-differentiation or integration, finding the integral.